So again, we're talking about the hypotenuse leg theorem. This is another way to prove triangles are congruent, but this only works for a right triangle. So we want to review what is a right triangle. It's a triangle that has a 90-degree angle, right? It's going to be something that looks like this. Is a right triangle. Has a 90-degree angle. Okay, so in order to use the hypotenuse leg theorem, we need to know what the hypotenuse and the legs are in this triangle. So in a right triangle, we have three sides, right? You have the two sides that are touching the right angle, and then you have the side that is not touching the right angle. Does anybody remember what we call those sides? The ones that are touching the right angle, those are called my legs. So this would be a leg, and this would be a leg. So every right triangle has two legs. They're the two that are touching the right angle. And then the side that is opposite the right angle, this is called the hypotenuse. It's the one that's not touching the right angle. So the new hypotenuse leg theorem, guess what we have to have congruent in our two triangles? We have to have one leg and the hypotenuse. Okay? One leg and the hypotenuse. You don't have to have both the legs, you just need one leg. What happens if you knew about both the legs? Then that would be the same thing as side, side, side. Right? If you knew all three legs about their congruence, or I'm sorry, all three sides and about their congruence, then that's the same thing as side, side, side. So what makes hypotenuse leg different is you need one leg, you need the hypotenuse, but it must be a right triangle in order to use it. Okay, it says here, Ashton is washing windows using a 10-foot ladder. For the first window, the ladder reaches the window when he places the base of the ladder at the rose bush. How can he determine where to place the ladder to be sure it reaches the last window? Okay, so when we look right here at this first window, we have a triangle. Right? Does everybody see that right triangle? So it looks something like, I'm going to draw it better. Looks something like this. The right triangle formed there. Okay, so do we know any of the lengths of this right triangle? We know it has a 90-degree angle. That's true. But we also know some of the lengths. We know one of them. 10 feet. What is 10 feet? The hypotenuse. The ladder is 10 feet. So the physical ladder here, the hypotenuse, is going to be 10 feet. Now we want to know, we don't know the distance on the bottom, but we know that it's the distance from the house to the rose bush, right? And we don't know the distance up the wall, but we know it's the distance from the ground to the bottom of that window, right? So what he's going to do is he's going to move the ladder to the other window here. So if he props the ladder up here to watch this window, what lengths will we know? Well, we'll still know 10 feet because the ladder still is 10 feet tall. Where does he want the ladder to be? He wants the ladder to be touching the bottom of the window. So the distance from the ground to the bottom of the window has to be the same as it was over here, right? Because it's on level ground. The house is built on level ground. So it's the same distance. So do I have enough to say these triangles are congruent? Yeah, I know that these sides are congruent, and I know the hypotenuse is congruent. So I know the hypotenuse, and I know a leg. So I could say those two triangles are congruent by the hypotenuse leg theorem. And so that means what distance does he need to move the ladder away from the wall? Well, it needs to be the same distance as it was here. From the wall, or from the house to the bush. Right, from the... I'm trying to find the word they use. They don't really use a word. Okay? It's the same distance. Angles are congruent using the hypotenuse leg theorem. So what would we need to know in order to say these two triangles are congruent? So look at the first triangle. What are we given? The hypotenuse is 9. Look at the second triangle. What are we given? We're given a leg. That is 5. So in order to say that these are congruent by the hypotenuse leg theorem, we need what in the first triangle?
A leg.
We need to know a leg. So we could say then that we need a leg to be equal to 5. So which leg do we think looks like it should be 5? The smaller one, which is MN. So we need MN to be equal to 5. And then that would work for the first triangle. In the second triangle, what do we need? We need to know the hypotenuse. And it has to be 9, right? So we would say that segment PR must be equal to 9. I have to write a proof to show that the triangle, that A triangle, is isosceles. So they're wanting to prove triangle ABC is isosceles. Okay. All right. So let's just go for it. So we've got our statements and our reasons. Statements and reasons. So what's my first statement going to be? The given. We always state the given first. So I'm going to restate that. I'm going to say FD is, do we know what that symbol means? Nope. Yes. Perpendicular is what that means. That means where they meet, they form right angles. So where FB and AD meet, FD and AB, they form a right angle. So they have that drawn for us here already. We also know that where FE and AC meet, we should have a right angle. So I'm looking at FEAC. They've already got that for us here. And let's see, what else do they tell me? They tell me that AE is congruent to AD. They have that marked for me. And they tell me that FC is congruent to FB. And they already have that marked for me. And all of these reasons are given. That's all one statement. Okay, so Okay, so when I look at this figure, if I'm wanting ABC to be isosceles, then that means I need to show that AB and AC are the same measurement, right? I see that from here to here and here to here, from A to D and A to E are the same. So I need to find that these little pieces also are the same. Because if the little piece is the same and the bigger piece is the same, then the entire sides are the same. So that's what I'm trying to look for. I need to find that these two sides are congruent.
The little
So
pieces are also right angles. They look like right angles. The little pieces.
the little piece here?
Yes.
Yes, that's the first thing. That's the part I was missing. So, because this is perpendicular and forms a 90-degree angle, that means I also have a 90-degree angle here as well. Right? So we could say that, like we don't actually have to say anything because we've already said that they're perpendicular. We just need to extend that information to show that if I have a right angle in one corner, I also have right angles there. Right? Just extending the information. So now, I'm looking, do I have enough to say any of my triangles are congruent? Because, again, I'm wanting this little one. If I can say that this triangle and this triangle are congruent, then by CP/CTC, these pieces will be congruent. So, I have the hypotenuse, but I don't have a leg, right? And since I'm trying to find these legs are congruent, then I'm probably going to find somehow these legs are congruent to start with. So when I look at these legs, they are shared with these two larger right triangles. Yes? So when I look here, do I have enough information to say these two larger right triangles are congruent? Well, I have this. This is a leg.
And A and F share the same lines, so that automatically means
A and F are shared, and they are what kind of line are A and F? What side of a right triangle are they?
hypotenuse.
They are the hypotenuse. They are opposite the right angles. So the first thing we want to say is we want to say that AF is congruent to segment AF. And the reason is because they're the same line. So that's the reflexive property. Okay, so now that I know these are the same lines, do I have enough to say that those triangles are congruent? I do, I've got enough. So let's go ahead and name it. I can say triangle. Let's go AEF is congruent to triangle, and then let's match it up. So A is going to match to A, E is going to match to D, and F is going to match to F. So I'm going to go with triangle ADF. And how did I know they were congruent? What was my reason? The HL theorem, by the hypotenuse leg theorem. They had the same hypotenuse and the same leg. So by the hypotenuse leg theorem, they are congruent. Okay, so now I've got two triangles congruent. That means all the pieces must also be congruent. Right, so when I'm looking, this is the other leg. This is what I really cared about, right? So now I can say that this leg, EF, must be congruent to FD because why?
Because the HL thing still.
Kind of. What did I just do? I just proved these two triangles were congruent. That means that all of the corresponding parts from this triangle are congruent to the corresponding parts in the other triangle. I could say that angle A and angle A here have to match. I can say that angle F and angle F there have to match. All the parts have to be congruent to their corresponding part. And so the reason I know that that works is CP, CTC. Corresponding parts of congruent triangles must be congruent. So now I have said that EF and DF are congruent. So is there enough information now to say that the two smaller triangles are congruent?
Yes.
There is. Because I know the hypotenuse and I know a leg. So now I can say the smaller triangles are congruent. So let's go triangle EFC is congruent to triangle. What goes with E? D. What goes with F? F and B. Right, and how did I know these were congruent? Because of the hypotenuse leg theorem again. And so as soon as I say they're congruent, what does that mean? That means all of the other parts are congruent to their corresponding parts. So that means this angle and this angle are congruent. It means angle C and angle B are congruent. It means that CE and DB are congruent. And so there's different ways you can do this. What I'm going to do, I'm going to say now I know angle C is congruent to angle B because of CP, CTC. Right? So angle C here must be congruent to angle B. And those are what? Those are base angles of the large triangle. And so now I have base angles that are congruent. Which means what about the big triangle? It's isosceles. If you ever have two angles congruent in a triangle, you know it's isosceles. You could have went and said these two little pieces were congruent, and then you could have said if I add those together, I get one big one, but I thought that would be more work. So as I do this. This is a little bit simpler. So because C and B are congruent, then that means that triangle ABC is isosceles. And how did I know that? Well, because I had congruent base angles. So my reason is congruent base angles. Right, so these should all match up. I did kind of a bad job matching them up. But everything, you have a statement and a reason. Statement, reason. Statement, reason. You've got line paper, so it makes y'all's a little bit easier. Right, I don't have lines up here. Okay, so again, I'm having to do a proof to prove that two triangles are congruent. So let's think about here what we're going to have in the end. They want to prove triangle JKM, which is here. We want to prove that it's congruent to triangle LKM, which is here. So we're proving those two larger triangles congruent. That needs to be my last statement. So again, it's always good to know what the end goal is. So my first statement is going to be just what's given to me. It tells me JL is perpendicular to KM. And it tells me JK is congruent to LK. And both these reasons they're the given. And you said I've already got all that filled out there for me.
Coach Coots, you know what this reminds me of? Where we had the two lines with the line through the middle. With the vertical angle. So that in the middle of it looks like you could turn any way, and that right angle is in the middle. See, I know what I'm thinking about, but I don't interpret it. Yo, and I'm thinking about it.
Okay, so does anybody see anything on this one that makes you think this is something else I could use? Like we know all of these are right angles, right? So that could be useful, or it might not be, right? But when I'm looking, I know, okay, if I've got one right angle there, all four of those are right angles.
Two legs are congruent to one another.
Okay, so we have legs that are congruent here. All right, when I was just thinking through it, we also have a shared side
Yeah.
here, but that would be another leg, right? So that's going to be,
That's a we have a hypotenuse on the leg.
we would have a hypotenuse and a leg, wouldn't we?
Yes.
Because the other sides that we know are the hypotenuse. So I'm going to say that Kn is congruent to Kn, and it's because it's a shared side, and the reason that we give is the reflexive property. Because I'm just restating that that side is congruent to itself. Well, I mean, obviously, it's congruent to itself. So now, I have a hypotenuse and a leg of those two smaller triangles. So I got enough to say that they are congruent. So I can say triangle, I'm going to go JKN must be congruent to triangle LKN. And that's because we had the hypotenuse leg theorem, right? We had a hypotenuse and a leg. Okay, so that means all the pieces that match up must also be congruent. So if I zoom in here, that means that this piece and this piece must be congruent. That means that this angle and this angle must be congruent. And it means that this angle and this angle must be congruent, right? All the pieces must be congruent.
Oh, okay. I thought we was finding J and M instead of JK.
Nope, yep, we're looking for the two big ones on the side. All right? So, if I look at my big triangles now, right, the things that I'm trying to prove, do I have enough to prove that the two big triangles are congruent to each other? Now, what do I know about the big triangles? I've got side here, and then I've got this
Side and
angle.
And then a half of another angle.
But let's think about it here. What do I need here? I've got a side. I've got that angle. I need another side. Can I say this side's congruent?
Because it's shared line.
Because it's shared, right? So I would have enough if I say that to use side angle side, right? Using one of my other methods that's up there. So let's go ahead and identify that shared side. So we could say that segment KM must be congruent to segment KM. And again, the reason is the reflexive property. And I never did state that those angles were congruent. You see my blue that's up there, the blue angles? I need to say that that's congruent. So I need to say angle JKN is congruent to angle LKN. And how did I know that? Well, because I proved those two smaller triangles congruent. And we said all the pieces had to match up. So that would be CPCTC. And now with that information, now I've got this shared side. Again, looking at the big ones. I've got the shared side. I've got that angle. And then I've got another side here. So I've got enough to say that the triangles are congruent. So I could say triangle JKM is congruent to triangle LKM. And my reason was side, angle, side. Had side, the included angle, and another side.